All right, that's the homework. Let's see. All right, so the one of the things that I'm finding out with all this is, does it seem like it's almost like a duplication of what we've already learned from chapter 10?
Yes.
Okay, just want to make sure I'm not going crazy. All right. All right, so let's go
Well,
ahead.
it's like the same thing of everything else, just different variables.
Right, just I guess it's called proportionate, right? So you just got to make
Yeah.
sure you say proportion instead of variables and stuff like that. So,
Yeah.
and the problem is I don't understand everything there either. So how about this? I don't speak Mathanese, so
Neither do I.
okay. All right, ready?
Yeah.
All right, first one. When given a sample, what is the formula for the point estimate for a portion? Uh, so basically, um, x over n. And the p hat equals x over n.
Yes. And you know
And
what? I have that, except for some reason I wrote 9.
well, that could work if 9 is one of them. There we go. Um,
Thanks.
so, and then x is the number of successes and n is the number of trials. So,
Yes.
all right. The confidence interval formula, formula is what I wrote down was basically the same thing as if we were doing chapter 10, but with the p hat plus or minus the z or uh, z score
Yeah.
to the square root of the p times the 1 minus the p over n.
Yep.
Okay. And then the next thing is, what is the conditions to which to build one of the proportion confidence intervals above? It is n times the p hat is greater or less than 10, or n times 1 minus p hat is greater than 10.
Yep.
Okay.
Greater than, less than.
Yeah, greater. Yeah, it's greater and equal to 10.
Yeah, equal to, you're right. I'm sorry. I have the equal to sign.
Yeah, understandable. Gotta remember, guys, start reading that Mathanese. All right, so for what is the formula to which you can get the n or the sample, or not, sorry, not the sample, it's the, size formula. And now this one was tricky though. You had to be a little bit careful because you don't know
Right.
when you know prior estimate of the population. So you got to make sure that's correct because that threw me off on one of the questions. So it's n equals the z-score over 2 times the margin of error squared. But when you do know when the p is available, it will be n equals n z over m squared times p times 1 minus p.
Ugh.
So,
Yeah.
okay. And then what number 6, what is the conditions? It's the same thing as number 2 with those NP greater or equal to 10 or n times 1 minus p equal greater or equal to 10.
Yep.
All right. Okay, we're going on to 7a. All right. P is equal to 684 over 1006. Comes out to 0.699. Why they have asked us to go to that decimal, I do not know. All right.
0.6799.
Yep. And then B in this case is taking the not the pop, whatever you want to call it, the trial size, 1,006, times it by the P, which is 0.66799, equal or less than the 10, so that makes it 684. And then again, you have to, or 1,006 times 1 minus 6.699, which comes out to 322 or 323. Because you can't have a side. Okay. And then determine the margin of error for 95% excuse me, 95% confidence. Again, it goes with 1.96 because 95% is
right.
And then square root the 0.699 times 1 minus 6.699 over 1,006. So your margin of error would be 0.288.
Yeah.
And then in this,
actually, you're missing a 0, but I don't know if that matters.
I'm sorry, and then I'm sorry. I always do that. 0.0288. Thank you. Thank you for being diligent on that.
Okay.
And then again, just the confidence intervals are 0.699 plus or minus 0.0288. And the numbers are 0.6511 or 0.7087.
Yeah.
Okay. All right. So how many college students? Again, this is asked, but we have no, when it's given the margin of error and we have nothing. So it's 1.96 over 2 times 0.015 squared. And the number comes out to
4,269.
Yay.
Woohoo!
Yep. Okay. And then the null and alternative hypothesis is P equal the HNP equals 0.6 or HA or alternative P is greater than 0.6.
Yeah.
Okay. Do this statistics on all this, taking the evidence from previous 0.6, this test statistic is 0.699 minus 0.6 over 0.6 times 1 minus 0.6 over 1,006, which comes out to 5.174.
Yeah.
Okay, and then put it in that on the you put it out on the applet, 0. Basically, well, it's so minute that it's basically go out to the fourth. It would be that. That being stated, it is less than the 0.05, so therefore we what?
Reject.
Yay. And then what is, state your conclusion.
We have sufficient evidence.
Yep, that within the students' car wrecks are in the last 5 years is greater than 0.6. See, that's the problem I always have is, stating that last one to be correct in what they are, but I guess it's just regurgitating what the last question is and either saying sufficient or insufficient.
Yeah.
So, all right. I mean, I hate to say it, but it seems a little bit
too good to be true.
Yeah, a little bit. I mean, so I'm going to call that good, and we'll go ahead and stop the broadcast, and we'll go on to the test.
Yeah.
All right. Yay.